we now have a video on CW Gold, something that I had mentioned about right at the beginning, and even Mr. Pratap Padode did talk about it in his welcome address. There is a five-dimensional benefit that you could avail by subscribing to CW Gold. This video is to give you some more insights. Can we have the video, please? The second session for today, ladies and gentlemen, will focus on innovation challenges and case studies. Mr. Sachin Kale, India BIM Lead, BuroHappold, and Mr. Muralimanoj Varadh-Rajan, Computational Lead, BuroHappold, will now decode design challenges with BIM. Mr. Sachin Kale is a mechanical engineer with over 23 years of experience in GIS and SMEP services. He has extensively worked with contracting and consulting firms for basic and detailed designs of structural building and GIS services on various BIM platforms. Mr. Muralimanoj Varadh-Rajan is a computational engineer with over 7 years of experience in structures, parametric design, and algorithm modeling. He has widely worked with consulting firms and contractors from schematic to detailed design of 3D models and generating fabrication drawings. And in this session, they will look at some of the iconic projects in Mumbai and how BIM was used in planning and designing of the projects. Thank you for joining us today. I now request Mr. Kale and Mr. Varadh-Rajan to take the discussion further. We have 30 minutes for the discussion and we're looking forward to this one. Over to you.
Thanks, Shali, for the introduction. I guess everyone can hear me.
Yes, we can.
Yeah, thank you. Yeah, so first of all, I'll just like to mention that I don't know, my colleague Murli is not onto the call. So I will try to cover up for all his computational part as well. But I may be the wrong person to answer the queries that may arise from the computational. Yeah, but then we definitely can update people and what is happening, and what basically in today's session we'll be looking into the challenges that we face implementing BIM during our designing and the planning phases. So let me share my screen and let's get started with the presentation. Hope everyone can see my screen now.
Yes, we can.
Okay. So as I said that we will be looking into the BIM challenges in the planning and designing phases, and how we at BuroHappold tackle them computationally. So all the challenges doesn't get tackled every time, but the common challenge or the major challenges, definitely we do have some computational workflows at that. And as Shriyal has already introduced me and Murli, so I'm just quickly going ahead of this big slide. And before moving on to the main topic of the BIM challenges, I know we had a very good discussion in the previous session regarding BIM, but I would just quickly like to take the forum as well with the advantages and the life cycle that we go on with the BIM things. So yeah, BIM is not a magic wand. Yeah, definitely BIM is a process which multiple stakeholders get together, adapt onto a project, and they deliver a project right from the design phase to the FM stage. So the complete life cycle is being covered and can be covered using BIM because it is a tool which each and every stakeholder or design team can implement onto their projects. So it is a process. It can be in form of some softwares, some processes, some workflows, which the team needs to implement onto the project. So looking at the BIM life cycle, as I said, that it starts, the BIM starts at very early stage from concept design, and it ends like goes on with the detailed designing. The same model can then be brought up into the analysis software, and the analysis can be carried out. All your documentation can be taken out or derived from your single BIM model. Same can be sent out for your fabrication. And if model properly keeping the 4D, 5D goals in mind, we can also like align these BIM models with your 4D, 5D softwares as well. The logistics can be maintained. Again, as I said, that again, during the handover process, the FM team can come over and take these models, which are rich in data and the information which they will be like requiring for all of the lifetime of the project, and then the demolition and the renovation as well. So this is the complete life cycle of BIM. Moving on to the advantages parts, like, so the first thing that we say is, yeah, so when we talk about BIM, people to have a image of a 3D model. Yes, you are absolutely right. BIM is like enhanced visualization, a power that everyone can have, higher productivity because of the easy retrieval rate, and the coordination process is also becomes easy because you remember old days when people used to coordinate between teams, taking the drawings. The coordination was not that easy. So using BIM as a tool for modeling, for coordination, it has like create revolution, and the coordination has also like become much more easier nowadays. Effective sharing of information also happens because the single model is the single source of truth. Everyone speaks up from the same model, so like it manages all the data inside it. So like you need not share any additional information when you're talking or sharing your information through BIM models. Clashes can be found at very early stages. So like the RFIs that come from site regarding the clashes and various processes can be like avoided with the early stages as well. As the model elements do have a good amount of metadata in that, so like then the extraction of the BOQs is also like very easy. And since as I said that it's a single source of truth, the loss of information, risk of losing the information is very low, and the result is the improved deliveries. So these are the main benefits using BIM. Now we just saw the good part of the BIM. So now let's come back to the main topic, like how what are the challenges that the industry faces using BIM or implementing BIM during the design and the planning phases. So as we know that the AEC is like rapidly growing, and all the projects are like I can say that on fast track, which demands faster inputs to the site to keep them running. And as we saw in the earlier slide, that BIM has got potentials to like cater to this need. And due to the lack of any authority being forcing BIM into India, yeah, it is coming in near future, but like still now we don't have any mandate on BIM, so it is going to come. But yeah, still it is not there. So like our industry is trying to, like the Indian industry is trying to catch up with the BIM part as compared to the Western countries. So the major, like in this today's session, we will like looking onto the major challenges that we face implementing BIM. The first or the biggest challenge that we see is like understanding clients' BIM requirements. So this is the major part. We should be very clear because technology vendors approach clients and they sell the tools, saying that okay, this is going to create magic wonders for them if they do use this on the project, and they do some fancy presentations showcasing the never-ending benefits. So because of that, what happens is like the client has got very high aspirations now. Like okay, if I use this, then my project is going to run very smoothly. But the thing that is missed out during these things is like they don't have proper requirement in place, or the vendors don't tell the client that okay, this is a complete life cycle tool that we are selling you, but it has got limitations or it has got partitions in between. So this part of the tool will be like catering to this design phase, and this part of the tool is going to cater for this design phase, which a design consultant may not be aware of, because normally design consultants are involved till the construction administration or till the tendering phases or the GFC stages. After that, it is been handed over to the client, and the client then handed to the contractor. Then it gets built and then goes to the facility. So the software that is being sold has got some limitations when it comes to the design stage. So those limitations should be made aware of when it comes to BIM, to the client and also all the design teams as well. And we should have a clear employer information requirement, or we say short form EIR, or a BIM scope, very clearly written. So that way, the majority of the challenges that arises at the initial conceptual or stages can be like avoided. So this is the major challenge that we see. Moving on, implementation of BIM at the right stage. So people do feel that okay, it is a 3D tool, then that can be like implemented as and when required. That is the misconception that is running around the industry. So we see that when BIM is implemented correctly at the initial stages of the project, it gives you good ROIs. So like definitely not on the single project, but like down the line, it gives you good return of investment. But yeah, if implemented at the start of the project, it can be like a boon to any project team. And then there's again lack of, as I was saying earlier, that there's lack of information like for the BIM documentation. BIM kickoffs don't happen. People start working in isolation using their own company standards. Then the BIM execution plan is not in place, which like highlights what actually are the aspirations or what is being needed by the client to complete the project. So lack of those documentation is also a major challenge implementing, because then companies start working on their own standards, and like they deliver a product which may or may not be in line with what has been expected. Then the standard approaches are not being followed. So like having a BIM consultant on board, or having a lead BIM consultant on board is a must. So which can be like those guys can guide the design teams or the client. Okay, this is what we need to achieve. This is the end goal, and all teams should focus working on to that aspect. So this is what like we should be like aiming at, and this is what is a challenge, that have lack of BIM documentation, then the BIM not implementing at the right stage, and non-standard approaches being followed by all the design teams. This is also a major challenge that we see. Lack of BIM knowledge and untrained staff is again a major challenge. As you may be remembering the days when people were working on AutoCAD. So like and earlier days were like the drafting boards. So people were reluctant to move on to like softwares like AutoCAD. The same is being a mindset of the experienced staff, I will say, not of the new joiners, because they're adapting to this BIM world. But yeah, as we say that we are working into this industry, so we need a mixed match of the experienced staff as well, and as the freshers as well. But the experienced staff is more reluctant to going and learning on to the new tools, and like then that hampers the production or the design processes that comes in. And because the experienced staff are well versed of what should be like followed in the coming time onto the project. So like that gets missed if the experienced staff is reluctant to adapt to the new changes. And again, when I say the new joiners or the fresh staff as well, so if they are not trained properly, so even they will be like creating some mess onto the projects, and the models may not get corrupt. So like so they will be like delivering to or producing some models that are not like in line with what the desired outcome may be needed. So that is also a main part of a challenge that we face. Lack of domain knowledge. So like when we say AEC in this, it is like it based on architectural, structural, MEP, mechanical, electrical, plumbing. So when we say that the domain knowledge is missing, so if someone from MEP is been asked to work on a structural or architectural element, so definitely he's going to lack on some part. So he may go and model based on the drawing that have been like assigned to him, but because of the lack of domain knowledge, he may model it wrongly. So that may also like that is also one of the challenge, because we see and we have experienced this on few of our projects that when unexperienced staff are being put onto a project, they definitely create some mess onto the project. And then the major part or the main part is like the staff quantity or the number of staff deployed onto a project not matching to the actual requirement. So like it may be a case that your project is like on a very fast track, and it requires like 15 to like 16 or 12 to 12 people working onto a project, and you're deployed only 6 to 7 persons or to finish the job. Definitely the result will be like they will be stretching too much, and the result coming out will be like messy models, or like then unclear models, wrong models. Like this is the outcome that maybe like we may see. So that was the second thing. The third part is like the limitations the software or the BIM software rather, I will say, has creating complex geometries. See, all the BIM software comes with some limitations when it comes to the complex geometries. So and we should be like aware of what are the limitations. So the staff should be like competent enough to see the normal geometry that we do is like pretty clear, and people can go around and play with the, say if taken an example of flat slabs. So the picture shows the roof is like bit curvy. So this this sort of complex geometries tend to like take time to model from a trained or experienced staff, but the untrained staff will consume much of your time preparing this sort of geometry. So yeah, so this is also a major challenge that people should be like very clear that okay, this is a complex geometry which I may not be modeling into my BIM software. So there are some alternate ways as well to model these complex geometries. So this is also something that people do face challenges implementing the BIM. And the biggest thing that we as a design consultant face is like the model element author. So like when we get or receive models from different stakeholders, so they start modeling up the part that they are not supposed to model. So and similarly, the things happen from structural MEP and the architectural guys as well. So like they start modeling the scope which is not like in their intended that they will be modeling. So people are not clear about their scopes. So this is something which affects the timelines and the costing as well for the projects. So the MEA should be very clear that who is going to do what, and they should be like restricting, the design team should be restricting them their scope to what is been asked. Like if MEP has been given to a certain design team, they should be only looking after the MEP part. Structural team should be only looking after the structural components. Architectural team or any facade team should be only looking after to their specific elements only, rather than modeling the other discipline elements. These things can be like a part of the scope, but or the part of your RFIs or something like that, that can go out to the different stakeholders or different design team, and then that can be sorted out, and the team can be asked to like take it to the proper level of detailing when it comes to the particular element from that specific discipline. So this is also a major part. Missing information into the BIM model. Again, this is a very biggest challenge that the industry is facing. People do tend to model the things in a rush, but the model that goes out don't have the required parameters. When I say required parameters, it comes to the quantity takeoff parameters, it comes to the 4D, 5D parameters, it comes to the broken systems, which then tend to lead to the incorrect BOQs as well, and the families or the parameters the family contains are also like generic or wrong, so which are not aligned with your BOQs or your schedules or your 4Ds, 5Ds. This is something like which hampers the next processes that follows your modeling process, or the handover or the tender processes also get affected by this incorrect modeling or information missing BIM models as well. And the biggest challenge, again, the model goes out to the clients or to the stakeholders without a proper QA/QC checks. So, like just for an example, MEP model goes out without proper materials or proper properties been assigned to the pipes. So, like there is a lack of QA/QC, which hampers these things. And due to this, definitely we do lose the intent that the BIM should be implemented onto the project for. So yes, missing information from the models is something, again, we should be like very like keeping an eye on. Poor quality of modeling. So this is just an example that I picked up. I already picked up in my earlier slide that domain knowledge plays a very key role. Like if I ask a structural guy to go and model my pipes, definitely something crazy that we see on screen will happen, because they won't be aware of the coordination process or how the pipe behaves with the different systems, or how they can be routed, the bends and everything, or the drops and everything. They are not aware of the processes or the system. So like lack of domain knowledge is something which is affecting the poor quality of modeling. And when we say about 4D, 5D, so like 4D, 5D is also like the models are definitely going to go ahead, because in today's world, BIM is playing a vital role of going and crossing it to the next level. So this is something that 4D, 5D also, the element that needs to be broken. So for example, the pipes or the slabs, the columns needs to get broken floor wise. So this is something that we should be like keeping an eye on. Experience stuff I already talked on, and the deadlines. The tight deadline is something that we should be like talking to the clients before we proceed. Okay, and coordination, again, this is something related to this slide, the first pointer, the coordination skills. So we should be like having a coordination meetings, I will say on a weekly basis to clear the coordination points with different stakeholders, that what are the things that has been needed and what are things that can be like kept on for the next stages. And tracking of the issues, and the important part is interoperability of various software, because different design teams may work on different BIM tools, but then their interoperability should also be checked before going and like working onto the projects. The biggest challenge that we face is like the client allowing some of the stakeholders to work on 2D world. So like when we say BIM, we expect all the stakeholders or all the design teams should work onto the BIM platform, so that the process of data retrieval, coordination, everything happens smoothly. But if some of your design teams are not working on BIM, then definitely this process of like coordination, data retrieval, data exchange is like going to like get affected, and we do see that there are chances of like rework to convert those 2D into the 3D. Software cost. Yes, the software, we may feel that the softwares are costly, but no, this is the only initial cost that we feel. The challenge that we see is like hiring the expert and training them. So like the training of your staff will like consume much of your cost, but the ROIs that will be getting down the line are very good, because BIM is here to stay. BIM is not going to go away from the industry, so it is here for good and is going to stay, and you will be definitely seeing the ROIs that we get from the various tools. Okay, having said that, I have focused, or I have thrown light on to the challenges that the team faces during the design and planning phases. I see Murli is onto the call now. Hi Murli. So like Murli will be like taking, because we are just seeing the challenges, but the way we deal the challenges at BuroHappold will also be like focused here. Murli, over to you.
Hi, thanks Sachin. Thanks for explaining the BIM and about its challenges. And from here, I will talk about what are the computation advantages that we have and how we tackle the BIM challenges using all these computation techniques. Next. Here, what we're seeing is like the computation workflows and its advantages. I'm pretty sure you guys are aware of the computation methods. These are one of the advanced methods that we use to improve the efficiency, and sometimes we use it to increase the model precision instead of the human error. We try to develop the scripts based on the algorithms. So we give some certain parameters, so all the engineers and even the clients can control the parameters to make some models very easily. And these softwares are used to even develop multiple interoperability between the softwares. So like many plugins, like user interface plugins, and sometimes we can pull some data from like the Excel software into the software that we need with ease actually. So we don't have, even if we have like a multiple softwares, and even if we have team of engineers who are specialized in certain softwares, it's not a problem. We can try to merge it. We can actually make the workflows smoother by using the computational techniques. It can also be used to detect the clashes between many complex geometries. If we have like a complex geometry and we don't know what are the elements, like for example, MEP elements and the structural elements clashes, we can develop a script actually that can actually detect all these things. And we can also automate a lot of tasks, like the usual thing will be the quantities, scheduling quantities, and or for example, shuttering quantities or any of the MEP elements that we need. It can be done very quickly. And we can also, not only that, in Revit, we also have the similar thing, but with the computation techniques, we can change the formats, and we can also add some other extra information as well. If we make the scripting right, these things are actually possible. Here you can see the computational workflows that is happening between various softwares and various domains, and it connects all the people from all over the domains, like the renderers, the graphic guys, and the BIM modelers, everyone can be connected using the computational workflow. And since we are dealing with multiple projects, right? Even the projects that we do, I mean, if it's the same project that we are doing all the time, it can be, even all these are repetitive tasks can be automated using all these computation techniques. So that's the main advantages of the computational. And let's see how we implement this in the BIM workflow to tackle its challenges. We already know like AEC industry is growing a lot. It's growing very fast. Since the age of AutoCAD to 3D modeling to like AR, VR, that's what we are doing. We are seeing it these days. The computational design actually encourages all these things. Like it is actually pushing all of us to go beyond what we can see from the out-of-box solutions. Yeah, mostly using advanced algorithms. Like the algorithms that we create can actually helps us to detect and make things even easier, like by combining all the methods and objects into and bringing into one platform. So we also have BIM that we use. I mean, whenever we get a project, we try to make a schematic sketches quickly, but this is not possible in BIM because BIM needs like a lot of information that has to be inputted in the beginning stage. But we use like computational tools, for example, like the tools like Rhino or Revit. For example, like Rhino is using Grasshopper. We can actually model many schematic sketches pretty quickly with some few parameters that can be edited. Like because in the beginning stage we have yes, okay, so yeah, like the input parameters that we have. So okay, next. We have a very computational application that we have between the many softwares that we already seen. Like in the first page, this is one of the example. Like even if we have multiple applications, we can actually connect between all these softwares, and we can extract all the information from it, and we can make it. We can make the workflow pretty neat. That's the computation application that we can actually insist upon. Next. Okay, it doesn't matter. Like many people think like computational design is like we need a knowledge of about raw coding. Like it's not like a traditional line-based coding. It's a visual programming. It comes like in a component wise. Like think like Python, we have like a bunch of internal frameworks, but it still needs some few lines of coding. But in case of visual program, you already have a components that can be plugged in together, like something like an electrical components. And even with a one-click solution, you can get it. Like once you open the task, you can click like you can do like a few clicks to do your tasks, to achieve your solution that you need. And so that's why you don't have to worry about thinking like it's a raw coding or something. Next. We can solve multiple software limitations using computational methods. For example, in using the BIM, where in previous days for the complex geometries we cannot export into the Revit if we are forming from the external software. But by using the computation techniques, it is possible because we have right now have a Rhino 7. It forms an interoperability between Revit and the Rhino 7. So in a few clicks, you can actually do it, and you can also set some parameters that can you can change the section or height, whatever we want, using the Grasshopper platform. Whatever changes you do on the Grasshopper, it's live on Revit. So it is achievable these days. Next. And by using the computational methods, we can improve the quality of modeling. Like I said before, various domains can be merged together. We need only like a basic domain knowledge and the coordination and enough coordination. So, the people are aware of this developed scripts. So they can just use it with a few clicks, like I said, and even some beginners can achieve the results that we need. It's kind of like using the software. Like in the previous days, we actually have to draw in hand, but these days we are using AutoCAD. Many industries are using it. Even the beginners can draw pretty good sketches, right? It's a similar way in using the computation methods. Even if you don't have much domain knowledge, only one member is enough to watch out what we want to achieve, and even the beginners with few clicks can actually model certain things and produce enough results for the clients within short amount of time. Next. And we can actually refine the coordination. For example, we can use builders work in Revit also. This is one of the things that we automate, and it's also one of the computation methods that we can follow. Using the builders work, it collects the opening information by using a small XML file. So when everything is checked, it cuts the holes. In addition, it also automatically alerts when the size or provision is changed, or even if the provision is deleted. That's the best part about the builder's work. And it can also, there are also methods. We can create clash detection for the collisions. And if there is a clearance zone, and if we have an object in the clearance zone, it can also show it. Like, okay, that we have an object in the clearance zone, so we have to clear it. We can also export all these clash reports to the client and also import the clash reports from the client, so we can compare various models, and figure out the way like how to actually solve it.
Mr. Varadh-Rajan, actually we are out of time. We'll have to conclude the presentation.
That was the last slide.
Perfect. Great. So on that note, thank you so much.